Coming to the parameter fan out means how many gates can you connect at the output of a given gate, or you can also define how many loads the given gate can drive. That is the fan out. It is also known as loading factor. For example, if you take two NOT gates, one can supply 5 milliamperes of current, but another NOT gate requires 1 milliamperes of current. So in this example, how many 1 milliampere gates can you connect at the output of 5 milliamperes gate? That is, you can connect only 5 only, because the first NOT gate can supply only 5 milliamperes of current. So therefore you can connect only 5 but not more than 5. Hence the fan out of this 5 milliamperes NOT gate is 5 only. Suppose if the NOT gate can supply only 3 milliamperes of current, 3 milliamperes of current, in this case can you connect 5 1 milliamperes gates at its output? No, because the first gate can supply only 3 milliamperes current, only 3 milliamperes of current. Therefore you can connect only 3 1 milliamperes gates only, not the 5. So therefore the fan out of 3 milliamperes NOT gate is only 3, right? So this is the fan. Therefore the fan out you can estimate by using sourcing current and the input current of a given gates. Okay, therefore with reference to logic high, the fan out is estimated by the formula IOH divided by IAH. With reference to logic low, the fan out is estimated using the formula IOL divided by IAL. So this is the logic high fan out and this is logic low fan out. Out of these two, which is a lesser value, that is the fan out of the given gate. Okay. Then coming to the parameter transition time. So we have in digital circuits two states. One is the on state and another one is off state. Here transition means a change from one state to another state is referred as the transition. So the amount of time the output of a logic circuit takes to change from one state to another state is called the transition time. So that is, so in this diagram, so this is the transition period between off state to on state, or this is the transition period between on to off state. Okay. So therefore two types of transition times you can say. One transition time is between off state to on state and another transition is between on state to off state. Hence two types of transitions you can say. One is the rise time and another one is fall time. So when will you call the transition time is rise transition time? So when the transition takes from logic low to logic high. Similarly, when will you call the transition time is fall transition time means if the transition is logic high to logic low. Okay, so that is the parameter transition time. Then coming to propagation delay, it means the amount of time taken by the circuit to change its output with reference to change in the input signal. In this example, the waveform represents the input and output waveform changes of a NOT gate. The first one is input side waveform, whereas second one is output side waveform. Because of gate delay, the output change may not in time with the change occur in the input. So that delay is referred as the propagation delay. Again here, because of two types of transitions, the propagation delay also you can classify as propagation delay between high to low transition, similarly propagation delay between low to high transition. Hence, the total propagation delay is the average of these two propagation times. Those are average of high to low propagation time and low to high propagation time. That is the parameter propagation time. Then coming to power consumption. Power consumption means the amount of power used by the circuit. There are two types of power consumptions. One is static power consumption and another one is dynamic power consumption. So when will you call the power consumption is static means the power consumed by the circuit when there is no transitions. Transition means, I said, changes from one state to another state. So without any transitions, the amount of power consumed by the circuit is referred as static power consumption. Whereas another power consumption is dynamic power consumption. This is the power consumption because of transitions. So without transitions, the power consumption is referred as static power consumptions. With transitions, the power consumption is known as dynamic power consumption. So out of these two, the more power consumption, the high power consumption value is dynamic power consumption, whereas static power consumption value is very less. And the dynamic power consumption can be estimated using the formula CL VDD square into F, where CL is the load capacitance value, VDD is the power supply voltage, and F is number of transitions or transition frequency. Like that you can estimate the dynamic power. So and the total power is sum of the static power and the dynamic power. So these are the different important parameters. Okay. So what are those? One is the noise margin, fan in, fan out, transition time, propagation delay and power consumption. Right?